In this lecture, we're going to talk about AI or artificial intelligence. And AI really just is intelligence shown by machines rather than humans or animals. Now, for the question, what is true AI? And this is a topic with so many different opinions. Through time, we've had a definition, or people have had a definition of what true AI is, but then when we reach that point, we change the definition a little bit. In my mind, as far as what I've seen, I don't think we're there yet. But I do think what we have is very highly simulated intelligence. That being said, IBM and Google are getting much closer. And some of the stuff that AI produces is pretty creepy. If you haven't yet, go search on Google for Google AI Dreaming. Both mesmerizing and creepy. AI right now is defined as something that perceives its environment and takes action to maximize the chance of success of some sort of goal. And it's supposed to do that not through programming or experience, but through reasoning. So in my mind, as far as I've seen, not quite there yet, but we are getting closer. Now let's look at a couple of the types of AI we use today. An expert system is a computer that emulates decisions made by humans, and they're designed to solve complex problems by reasoning about their own knowledge. Mostly, this is if-then statements, or rules than normal procedural code. Expert systems have two subsystems. The knowledge space has all the rules, all the facts, and then the inference engine applies those rules and the known facts, and then deduct new facts. Then we have ANNs, artificial neural networks, and they're inspired by the human brain. We make the decisions based on thousands and thousands of memories, stories, situations, or other factors that we have. All those things we have experienced and learned through our lives, we use to make that decision. The ANN emulates that. So the system learns, it improves its own performance every time they do tasks. And they generally do that without specific programming for that one task. I think I've talked about this example before. There are pictures that are labeled gecko, and there are pictures that are labeled no gecko. And through those images, the ANN can learn to identify geckos in other pictures or identify if there are no geckos. And I know this is an oversimplification of how they learn. But in its basic, that is how they learn. The ANN is based on connecting units called artificial neurons, hence the name. And the neurons are normally structured in layers where the different layers perform different transformations on their input. So as the signal travels from the first to the last input, it goes through multiple neurons and multiple layers. And then as the last type of AI we're going to look at, we have genetic programming or GP. With GP, each program is encoded with a set of genes or instructions, and they're modified as the program evolves using an evolutionary algorithm. And that algorithm would most often be a GA or genetic algorithm. And the result of these computer programs are that they're able to perform one predefined task. It gets evaluated on how well it does that one task, and then depending on the outcome, it either might get retired or it might get evolved, meaning the genes or instructions of the code is modified. And as the genetic programming evolves the programs, they're traditionally represented in memory as tree structures because it's easier to evaluate them in a recursive manner. Every tree node has an operator function, and every terminal node has an operand, which means that mathematical expressions are easier to evolve and evaluate. And since GP uses that tree structure, it favors programming languages that lends itself to that tree structure. That could be Lisp or other functional programming languages. And this is a very simplified version of how genetic programming works, just like everything else on the exam. But you start out with generating that initial publication of random computer programs, and then we assign them problems to solve. We look at how well do they solve that problem, and with that result, we create a new population of computer programs. We then copy the best existing programs. We create new programs with mutations or crossovers, so the name kind of makes sense, right? Genetic programming. We take the traits from one program that's the best at solving a specific problem, and then we evolve them. And a lot of what we're seeing right now with AI is, let's see if it can do stuff. So genetic algorithms and programs have been used to play Pac-Man, robotic soccer. It has been used in NIDS, network intrusion detection systems. And really in everything we do, there are a ton of applications where we can use AI, where the outcome is going to be so much better because we do. And I'm assuming over the next 5 years or so, we're going to see it in so many more things. we're going to see it everywhere. Either it's going to do great things for humanity, help us progress, or, maybe Skynet. Who knows? And with that, we are done with this lecture. Thank you for being here, and I will see you in the next one.